So we're going to pick up with labeling the periodic table. You should have downloaded and or printed a periodic table that looks similar to what you see here. And we are going to work through labeling this with all the things we need. So the first thing we're going to do is we're going to flip back and forth a little bit. So we have what we call rows and columns. Okay, so we're going to label our rows, which are also called periods, with numbers. And the nice thing is it just goes straight down the column, all the way down. Now, these two elements, rows, are actually squeezed right up into here. So this is technically row 6 and row 7 as well, even though it's basically cut and removed to keep the table organized. Now, one thing we see is that there's atomic numbers. So the number at the top left corner are our atomic numbers. And we know that they go in order of 1, 2, 3, 4, all the way across until we get to 118. So that's our first thing. Now, the next thing it said to label. So these are our rows, or called periods. The next thing we're going to label are the columns. And now the nice thing about the columns is they are actually already labeled. So if I'm looking at this right here, I'm going to erase on the top of each column, there are 2 numbers. And each number is going to tell us something different. The first number is telling us what row, 1 through 18. There's 18 columns on the periodic table. The second number is going to tell us 2 things. The first is if it's in an A group, it's going to tell us how many valence electrons that element has. So you might be asking yourself, what's the A group? Well, to tell you, I'm going to highlight them in yellow. So if it has a Roman numeral with an A, that is an A group element. If it's underneath a column that has a B, it is going to be a B group element. Okay, so you see all of our B's. Make sure I highlighted everything okay. So our A's, these are often called main group or representative elements. The nice thing about writing on this is that if I highlight, it's not going to smear. The ones in blue, on the other hand, are called transition elements. Okay, so that's one way we classify them. Whether or not they're a main group, meaning they're in the A's column, or if they're in the B and they're transition metals. So you'll see here that we kind of exclude the bottom 2 rows from that, and that's okay. All right, so we should have labeled rows, periods, our A and B groups. Now let's go back to looking at this valence electrons. So if in the A group only, because the B groups, we're not going to worry about valence electrons, it goes from 1 to 8, which means, because remember, we're looking at the Roman numeral, this has 1 valence electron. Everything in this column has 2 valence electrons. This column has 3, this one's 4, 5, 6, 7, you guessed it, 8, all the way across. So only in the A group, the representative elements, we can count the valence electrons like that. The ones that are in the B group, in the blue, their valence electrons can vary, and so we can't apply a predictable rule like that, though within the column they have similar relationships. So when we have these elements classified based on their valence electrons, they are kind of like a family, which is why we call them columns, groups, or families. Because if you're in a group, you have something in common. If you're in a family, you have something in common. These elements have a few things in in common. They have the same number of valence electrons. They have similar chemical and physical properties, which makes them kind of like a family or a group. So let's go back. So we did families, groups. Now we're going to label some specific families. So when I'm looking at group 1A, which is the first column, these elements are going to be called, find the right spot, alkyl metals. ALKALI metals. Group 2A are going to be alkaline earth metals. So ALKALINE, earth, EARTH, metals. On the other side, I'm going to have in group 8A, these are going to be our noble or inert, INERT, just like the physics term we learned, gases. And then right next door to that, group 7A, these are going to be our halogens. So now, group 3A, 4A, 5A, and 6A do have names, like family names, but we don't typically worry so much about them or teach them, so we're not going to worry about them. You need to know the four that are here: the alkali metals, the alkaline earth metals, the halogens, and the noble or inert gases. So what this brings us to is a really important concept that we're going to cover in just a few chapters about the rule of 8. And what you need to know is that the reason why these are called noble or inert gases is because the term noble is supposed to suggest nobility. Everybody wants to be noble, therefore having 8 valence electrons is desirable. So every element that doesn't have 8 wants to get to 8. The other part is that they're inert, which if you remember about inertia, it was the resistance to have a change in motion. Well, in this case, inert is going to mean they're not very reactive. So they don't like to undergo chemical reactions, which when we get to chapter 9 called chemical reactions, it's going to be very important that these are inert. All right, we named these. We did our A group and our B group families. So you should have almost all of your periodic table labeled. There's going to be one thing we're going to add, and we're going to add it to the bottom. And the reason why we're adding it now is because it's going to become important in the next chapter. And this is the predicted charge. So just like the yellow elements have the same family name, the same number of valence electrons, they're also going to adopt the same charge, meaning they're going to lose or gain electrons in a predictable way. So everything in group 1A is going to want to be 1 plus. Everything in 2A is going to want to be 2 plus. So this means group 1A elements want to give up the 1 electron they have. The group 2A elements want to give up 2 electrons. Because remember, losing something negative makes your life more positive. When I jump across, these tend to be 3 plus, and then something changes. When I get to group 4A, these elements either like to be 4 plus or 4 minus. They're either going to give up or gain 4 electrons. Then it's going to start going backwards. 3 minus, 2 minus, 1 minus, and then 0. Because remember, noble gases don't want to gain or give up electrons. They are fine just the way they are. They have 8. So if we think about the periodic table like a game board, when fluorine gains an electron, it's going to hop 1 space to the right. When sulfur gains 2 electrons, 1, 2, it's going to gain 2 electrons and move 2 spaces to the right. And then all of a sudden, they're in the noble gas column. And that's where all elements want to be. So when elements gain and lose electrons, it's solely going to be to move on the periodic table like it's a game board, and the electrons are the number of spaces you can move. So the final way we're going to classify our elements is by whether or not they are a metal or a non-metal. So, and I know this is kind of messy, the way the things are lined up. But what this says is that the valence electrons, which we defined as the 1 through 8, are going to be in the outer shell, and they determine the chemical properties. This was group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. You'll see there's only one exception. Helium only has 2 electrons, so it doesn't have the full 8 that all the other elements in its column has, but it's because it's a very small atom, doesn't have room for 8. The noble gases, we said, have the filled shells, they're inert. If the elements have 1 to 2 electrons available, they are going to want to lose their electrons. We call these metals. If the elements have 5 to 7 outer electrons, they're going to want to gain. And we call these nonmetals. And we have to think about this in 2 ways. One is, would it be easier for lithium, let's do sodium, to gain 1, 2, 3, 4, 5, 6, 7 electrons to get to 8? Or would it be easier for it to give up 1 and just move back a space to neon? Obviously, it's going to be easier for sodium to give up 1 electron and move back a space than move 7 spaces forward and get to argon. So that's the same thing applies for 1A, 2A, 3A. They have fewer spots to move back and get to a noble gas than they have to move forward. It would take more. And the ones that are in 5, 6, 7, well, they only are a few steps away from getting into that last column, so they're just going to gain a few electrons to get there. The column that's kind of in the middle is 4. They're halfway in between. They could lose 4 or gain 4. So they're going to behave differently based on whether or not they are a nonmetal or metal. And so we have one more further classification, which is metal, nonmetal, semiconductor. So let's go back to our periodic table, and we're going to draw in a line. Now this line is really important. Make sure I went too far down. That one's not complete. So this line right here is the line of division. Now, when I'm looking at whether or not something is a metal, anything that's to the left of that line, pick a different color. So all of these, and then all of the elements down here. Okay, now these elements down here, the first row, they're called lanthanides. Lanthanides. The bottom one is called the actinides. Actinides. So they're going to be metals. They get to be grouped into this classification. Now, nonmetals, they're going to be the elements that are over here. Okay? But there is a problem, because what do we do about the elements that are right here on the red line? Are they always definitively going to be a nonmetal or definitively a metal? And if we go back and we look at this image here, we're going to see that there are 7 elements which are going to behave kind of as both, a metal and a nonmetal. They're going to be dependent on the situation. So let's highlight those a different color. So we have boron, silicon, arsenic, beryllium, and astatine. Make sure I get those all right. And then we have germanium and antimony. Now, depending on the author of your text, sometimes they would highlight aluminum, polonium. Some of them just say if they even touch the red line, they're a semiconductor, but this author of the book picks these 7. Okay. Now, to be a semiconductor, it means that just like we talked about conductors and insulators, it's going to depend on the conditions, on whether or not they behave as a metal or a non-metal. So they're kind of an in-between. They're not quite clearly a metal or a non-metal. But everything else to the left is going to be a metal, and everything else to the right is going to be a non-metal. All right, so you should have, I'm going to leave this up here for just a few seconds, you should have your periodic table labeled. Just make sure you complete the rest of the assignment for this particular chapter, and then you should be all done. Let's go back and make sure. Yep, we finished the end of our slides. Okay, so